If you guys are still writing this down, that's okay. I am going to go ahead and start talking through this just a little bit, though. Do you guys remember in Algebra 2 doing polynomial long division and synthetic division? That's what we're going to be reviewing today. Polynomial long division and using synthetic division. The first two examples I want to use long division on. So they want us to find the quotient and the remainder if f of x is divided by p of x. So p of x is our divisor. This is the part that goes on the outside. And that means that f of x is our dividend, the part that goes on the inside. So when I set up my division, I'm going to put 9x plus 4 inside like this, and 2x minus 5 outside like this. And then just like when you learned how to do long division in elementary school, we want to figure out how many times does 2x minus 5 go into 9x plus 4. And we usually only really pay attention to these first pieces. I want to know how many times does 2x go into 9x? How many whole times can 2x go into 9x? 4. So I'm going to put 4 up here. And then I take that 4 and I distribute it to both pieces of my divisor. So I would have 8x minus 20. Does anybody remember what I do with it at this point? Change the signs. We're going to subtract this polynomial that we just found. We're going to subtract both parts. So both signs are going to change there. So I have 9x minus 8x, which would leave me with what?
Negative x.
Not negative x.
Oh.
Just a positive x, because I have 9 minus 8. If it was the other way around, you're right, it would be negative. And then I have 4 minus 20? Plus 20, because both signs change. So when I combine those together, I get what? 24. Can 2x go into x? No. So then this right here is my remainder. So that would be r of x. And up on top, this is my quotient, which we are calling q of x. So when I go to write q of x and r of x, q of x would be 4, and r of x would be x plus 24. How could I check that using the division algorithm if I wanted to? What could I do to check that?
Substituting it into the equation.
Normally I could, if I was finding a final value. In this case, I've kind of factored it. Our division algorithm says that that original function f of x is equal to my divisor, p of x, times my quotient, q of x, plus my remainder, r of x. So if I substitute in the polynomials that I have for p of x, q of x, and r of x, I can multiply and combine like terms and make sure that I get my original function back. So my divisor was 2x minus 5. I'm actually going to change that and write that in red. What was our function q of x? 4. So I'm going to take that whole thing and multiply it by 4. And then we would add our function r of x, x plus 24. So then I would distribute the 4. That would give me 8x minus 20 plus x plus 24. What do I get when I combine those all together? 9x plus what? 9x plus 4. Is that the original dividend, the original function that I had?
Yeah.
Yes. So I know I did this correctly then. You do not have to check every single problem, but it's important to know that you can check and see if you're correct. You guys okay to try another one like this? All right. Is everybody okay if I change the screen? Let's put up our next example then. Which piece is going to go on the outside? P of x, right here. Here's my divisor. So that's going to go on the outside, x squared minus 3. And then I get my big, huge division sign here. 2x to the 4th minus x to the 3rd minus 3x squared plus 7x minus 12 goes underneath. At the beginning, really only paying attention to those front parts. 2x to the 4th and x squared. I want to know how many times x squared can go into 2x to the 4th. Yep. But I also have to pay attention to the degree there, so I can pull it off to the side and divide it. I see the 2, but I'm still going to have a variable, x squared. So 2x squared is what I'm going to put up on top. I would not take off points if you guys don't do this particular piece just like me, but what you're supposed to do when you do long division is you're supposed to keep your place values lined up. So I put it over that minus 3x squared because that's my x squareds column. Kind of like you have your hundreds place and your tens place and your ones place. If you don't line them up, I'm not going to take off points for that. That's not super important for me. But I do always try to make sure that I have them lined up when I do examples for you guys. So now I'm going to take that 2x squared. I'm going to distribute that to both pieces in the front here. 2x squared times x squared. 2x to the 4th. And that should always match that first piece because you want that to cancel out entirely. 2x squared times negative 3. Negative 6x squared. Should I put that right here? No, I need to put it underneath the like term, so it needs to go underneath the negative 3x squared. And then what do we do with that now? Change your signs. We're going to subtract this polynomial. So I have 2x to the 4th minus 2x to the 4th. Cancels out. What do I do with that negative x cubed? Bring it down. So minus x cubed. What is this next piece going to be? What are we doing to that polynomial again? Change our signs. We're subtracting our polynomial, so that's not a minus 6. I'm subtracting a negative 6x squared. What happens if I subtract a negative? Becomes positive. So I have a negative 3x squared plus 6x squared. So this is going to be plus 3x squared. And then I'm going to bring down the plus 7x and bring down my minus 12 here. So far, so good? Remember, we have to distribute that subtraction, so we're changing both of the signs. That's why it's a plus 3x squared. And then we do the whole thing all over again. We start back at the beginning. I want to know how many times x squared is going to go into negative x cubed. So one time. Also pay attention to your degree. If I divide those, what would I get? Negative x. That's what I need to put up on top. So I'm going to have minus x up here. And then I take that and I distribute it to both pieces of my divisor. Negative x times x squared, I get negative x cubed. Negative x times negative 3?
Negative 3x.
So close.
Negative 3x squared. Negative 3x.
I have negative x times negative 3.
Oh, negative 3x.
Positive 3x. Why is it a positive?
Wait, because it's two negatives.
It's two negatives. I'm doing a negative times a negative. So negative x times negative 3 gives me a positive 3x. Then we're going to subtract both pieces. So on your paper, change your signs so that you remember.
Why did we skip 3x squared?
We did not skip the 3x squared. We're going down in powers. Remember, we had to drop down that. Oh, why did I leave it blank? Because when I distributed, I didn't have any x squareds. I had a negative x cubed, and I had a positive 3x, so I lined them up underneath their like terms. Does that make sense? It's because we have an x squared as our divisor, and then the next piece of it doesn't have an x with it. Does that make more sense? Okay. Negative x cubed plus negative x cubed. Or sorry, minus negative x cubed. I said the wrong thing. 0. Those are going to cancel. You always want those front pieces to cancel. When I subtract a negative, that turns into addition, so it's going to cancel out. What happens to that 3x squared? Yep. Stays. Bring it down. 3x squared. And then I have 10x, right? No, why not? Change your signs. We are subtracting whatever we wrote down after we distributed. Whatever we wrote down after we distributed, we then subtract. So I'm going to do 7x minus 3x. So that gives me 4x. And then I'm going to drop down this minus 12. All right, this should be our last time through. How many times will x squared go into 3x squared? 3 times. Do I need to worry about that degree at all?
Nope.
Nope. 3 is what I put up on top. Plus 3. So then I'm going to take that 3. I'm going to distribute it to both pieces of my divisor. So I get 3x squared and negative 9. We're going to subtract that entire polynomial. 3x squared minus 3x squared. 0. That's going to cancel out. What do we do with the 4x? Drop it down. What's my last piece going to be? So close. Negative 3 or positive 3? Negative 3. So minus 3. Does x squared go into 4x at all? Nope. This is my remainder. So that is R of x. What is my quotient, Q of x? All the numbers up here from the division. Here's my quotient. So Q of x is equal to 2x squared minus x plus 3. I'm not going to do it right now, but how would I go about checking this if I wanted to make sure I was right?
Substitute in for f of x equals.
Yes, substitute it into that division algorithm. I would take P of x, multiply it by Q of x, and then I would add that to R of x. All right, you guys okay on this so far?
Yeah.
Okay. We are going to talk about the remainder theorem next. The remainder theorem says that if I take a polynomial and I divide it by x minus c, then the remainder is what f of c would evaluate to. And to do these problems, we are going to use synthetic division so that we have a chance to review that as well. We could do these using long division, but I want an opportunity to practice reviewing synthetic division as well. For synthetic division, we do not use the whole factor. We want to use the root, or the 0. If my factor is x minus 3, what is my root? 3. So I'm going to use 3. And then I'm going to write down the coefficients from my polynomial. I'm not going to write down any of the x's. I'm only writing the coefficients. I'm going to start with the highest power. What's the highest power of x? 3. What's the coefficient in front of x cubed?
1.
A 1. So I'm going to start with a 1 right here. Keep my root off to the side. Then I have to go to the next power of x. So after x cubed, if I go down, that would be x squared. What's the coefficient in front of the x squared? -4. If I keep going down in powers, x cubed, x squared, what would come next? Think about my powers of x first. X cubed, x squared, x. What's the coefficient in front of x? 0. We have 0 x's. I have to include that. We start with the highest power, and you have to include every power of x. So if you don't see it there, you have to put the 0 in. And then we put our constant in, -5. And I always block that constant out from everybody else because back here is going to be our remainder. So far, so good? Okay. So when we do synthetic division, whatever that first coefficient is, it comes straight down. So I'm going to have a 1 down here. Then you take your root, you multiply it to that coefficient. So I do 3 times 1 and I get 3. I write that down right here, and I'm going to add that to the coefficient above it. -4 times 3? -1. And then I repeat the process. I'm going to multiply my root to that new coefficient. So I have 3 times -1 That would give me -3. And I add it to the coefficient above it. 0 plus -3 would give me -3. And then we do it one more time. 3 times -3? -9. And we add those together. -5 plus -9? -14. This is what we were looking for in the problem. This tells me that if I evaluate f of 3, my outcome would be -14. These coefficients up here, the 1, -1, -3, it would drop 1 power, so that would be 1x squared minus x minus 3. That would be my function q of x. Drops 1 power from my original. Let's look at this real quick. I want to check this and see what's going on. If I take 3 and I substitute it into that function f of x, so I would have 3 cubed minus 4 times 3 squared minus 5. What is 3 cubed? 27. Minus 4 times 3 squared. 3 squared is 9. So minus 36 minus 5. What is 27 minus 36? 9. -9 minus 5. -14. Somebody asked me earlier today, so does that mean we can just substitute in and get it that way? If the problem is asking you to use the remainder theorem to show this, I need to see either long or synthetic division. You can check it by subbing in so that you know you've got the right thing, or you could sub in at the beginning so that you know what your remainder is supposed to come out to be. But on a problem where I'm asking you to show me this using the remainder theorem, I want to see long or synthetic division, and I want to see that that remainder is there. All right. Let's do part B. Same polynomial, different root. What is our root this time?
X plus 2.
That's my factor. -2. Remember, this right here is a factor. Root is where it would touch the x-axis at. All right, so I'm going to have -2 on the outside. Come on. What's the very first thing I do when we are doing synthetic division? Yep. Bring that first coefficient straight down. Then what do I do?
Multiply 1 to the root.
Yep. Multiply that coefficient to my root. So I get -2, and I'm going to put that answer right here. So far, so good? What do I do with those two pieces? Add them. So I have -4 plus -2. I get -6. Then what?
You get positive 12.
Positive 12, because I do -2 times -6. Then I add these two together. I get just a positive 12, right? And then one more time, we multiply. -24. And I'm going to add that to the -5. Which gives me what? -29, thank you. So this is what I was looking for in the problem. If we evaluate the function f at -2, the output would be -29. Doing all right with that? Let's do 2 more examples that are just like this one. I want to use synthetic division again. And we are going to use the remainder theorem. New polynomial this time, though. Go ahead and do both of these. Make sure you write down your root first, not your factor, but your root. Make sure when you're writing down your coefficients, you start with the highest power of x, and you get every power below that. If it's not there, you put in a 0 in its place. On part A, don't worry if your numbers get large. They are supposed to. Give me a quick thumbs up if you're done with the first one. What did you guys get the remainder to be on the first one? How much? 130. Let's go through that real quick. Oh, I wrote that in the wrong spot. Scoot that over to the correct one. There we go. So I would take my -3, multiply it to the 1. I'd have -3 here and add that. That would give me a -4. Multiply again. I would get 12. When I add that, that gives me 14. -3 times 14. Give me what? -42. Add that to the piece above it, and I get -46. -3 times -46 gives me a positive 138, and when I add that to the -8 above it, I get 130. Awesome. What about the second one? What did you get the remainder to be there? 0. And that is correct. So I would take -1 and multiply it to the 1. Add these together. That would give me -2. Then I would have a +2. Add those together. I get 4. -1 times 4 gives me -4. Add those together. I get -8. Negative times a negative gives me a +8. And when I add those together, I get 0. Awesome. It's kind of special that I got 0 as my remainder. Does anybody know what that means about -1? It's an intercept. It's an x-intercept. -1 is a root or a 0 of our function. Which means that x plus 1 is a factor of f of x. If we use long or synthetic division with a polynomial and we get a remainder of 0, that means that we have found a factor of that polynomial. That is our factor theorem. I'm going to put the factor theorem up on the board real quick. If f is a polynomial function, f minus c is a factor if and only if the remainder is 0. Practice just a little bit more with synthetic division. That'll leave us one piece of 4-2 that we need to finish up tomorrow. Your 4-2 homework will be due tomorrow night. I've posted the problems in Canvas. There's a PDF. The Canvas assignment itself will be ready later today after school. So you can work on it on paper and then upload your answers as soon as I have that live. It should be live by about 5 o'clock today. All right? All right. I'm going to put up the last 3 problems that I want to do with you guys. We're going to use synthetic division, and we want to write both q of x and r of x. The last several problems, we've only been focusing on r of x. I want to write down both q and r using synthetic division. So what is my root on the first one on part A? 2. So I need that on the outside. I need my coefficients inside, starting with the highest power of x. What's the coefficient on the highest power? 2. And that's an x cubed, so then I move to x squared. What's that coefficient? -3. Then I move to x, 4, and then my constant, -5. And I always block that guy off because I know back here is where I'm going to find r of x. First coefficient drops straight down, so I have a 2 here. And we're going to multiply. 2 times 2 gives me 4, and then I add, which gives me what? 1. Multiply again, that gives me 2, and then I add. 4 plus 2, I get 6. What do I get after the last time that I multiply? Yep, I have 12, and then I add them together. You're right. My remainder is 7, so here's r of x. R of x is 7. Then I still need to write q of x, my quotient. I have all of the coefficients, but I need to know what powers of x go with each piece. What was the degree of my original polynomial, f of x? 3. So this is degree 3. What was the degree of the polynomial that I was dividing it by? 1. I took a degree 3 and I divided it by a degree 1, so it's going to go down 1 degree. So this is going to be my x squareds. This is going to be my x's. This is going to be my constant. So q of x is going to be 2x squared plus x plus 6. Part B, what's my root? 4. So I have a 4 on the outside, and then I need my coefficients starting with the highest power of x. So what's my first coefficient? 3. That's x to the 5th, so then I have to move to x to the 4th. What's the coefficient for x to the 4th? 0. X to the 3rd? 0. X squared? 6. X? 0. And then my constant? 15. You have to get those zeros in there. If you don't, it is incorrect. So here's where r of x will end up. Drop that first coefficient straight down. Multiply and add. So I get 12. These numbers are going to start to get big. I have 48. And then I add. Now I have to do 48 times 4. What is 48 times 4?
192.
192. And I have to add that. So I have 198 here. Then I have to do 198 times 4. What is 198 times 4? 792. Add those. 792. One more multiplication. 4 times 792. 3,168. We add those together. What is my remainder, r of x? 3,183. So r of x, 3,183. What is q of x going to be? I know it has a 3. What's my power of x there? X to the 4th, because we divided it by a degree 1, so everything's going to drop 1 degree.
3 to the 3rd.
Yep.
I mean to the 4th.
Yes, 3x to the 4th
Plus 12x
plus 12x cubed.
plus 48x squared
Yep.
plus 198x plus 792.
Plus 792. Looks good. We'll finish up C and the last couple ideas that we need to cover in 4.2 tomorrow. We are going to go ahead and start on 4.3 tomorrow as well. All right? Please let me know if you guys have any questions. Send me messages in Canvas, please. I hope you guys have a fantastic rest of your day.